Hi, Assalamualaikum and good day. Today we are going to learn more about limits of functions. Today's session is a continuation to our last session on limits. If you recall, in the last session, we have learned on how to compute the limit of functions as x approach to a real number. For polynomial functions, we use direct substitution. For rational function, we use either direct substitution, factorization, or rationalization. And as for trigonometric function, we apply the property of limit of sine x over x as x approach to 0 equal to 1. Today, we will continue with solving limits as x approach to positive, negative, infinity for the following types of functions. There are few important properties that you need to know regarding limit of f as x approach to infinity as stated below. Let's start with the polynomial functions. To compute the limit of this type of function, you may apply direct substitution. For a and b, by direct substitution, you will get positive and negative infinity respectively. As for c and d, by direct substitution, you'll get both answer with negative infinity. Take note that limit of x to the power of n as x approach to positive infinity is always equal to positive infinity. Limit of x to the power of n as x approach to negative infinity is equal to negative infinity if n is odd, and it is equal to positive infinity if n is even. Next, proceed with example 17, which is also on polynomials. For polynomial with more terms, you can just take the highest degree of x term in the calculation of limit for both a and b by substituting the corresponding x value into the highest degree of x term. You will get positive and negative infinity respectively. Example 18 is on rational functions. In order to determine the limit, divide both numerator and denominator by the highest degree of x in the denominator. For a, given that the highest degree of x in the denominator is 1, so by dividing both numerator and denominator by x and simplify, you will get 4 plus 7 over x over 8 minus 11 over x. Replace x with 0 and simplify, you will obtain 1 over 2 as the final answer. For b, the highest degree of x in the denominator is 3. By dividing both numerator and denominator by x to the power of 3, simplify, then replace x with infinity, you will get 0 as the final answer. Take note that any number divided by infinity, the answer is always 0. For c, the highest degree of x in the denominator is 1. By dividing both numerator and denominator by x, simplify, then replace x with infinity, you will get positive infinity as the final answer. Alternatively, you may also solve the limit of rational function as x approach to infinity as follows. As both numerator and denominator are polynomials, we can just take the highest degree of x term and replace x with the corresponding value. You will get the same answer as stated in the first solution. Now, refer to example 19, which is on radical functions. For a, as both numerator and denominator inside the square roots are also polynomial, we can just take the highest degree of x term. Replace x with the corresponding value, you will get the final answer. For b, the highest degree of x in the denominator is 1. By dividing both numerator and denominator by x, simplify, then replace x with infinity, you will get 1 over 3 as the final answer. C is the same with b, just that now the x approach to negative infinity. For x approach to negative infinity, you need to consider negative x. Do the same process as in b, then replace x with negative infinity, you will get negative 1 over 3 as the final answer. For d, you need to simplify the function using the rationalization, that is, by multiplying both numerator and denominator by the conjugate of the third, that is, square root of x to the power of 6 plus 2x to the power of 3, then plus with x to the power of 3. Simplify the function and then substitute x with positive infinity, you will get 1 as the final answer. Example 20 is on trigonometric functions. To solve the limit, you may bring the trigo sign such as sine or cos outside the limit and solve as usual. For a, by putting the cos and the constant outside the limit, you only need to find the limit of 1 over x. Replace x with positive infinity, the answer is equal to 0. As cos 0 equal to 1, the final answer is 1. For b, by putting the sign outside and by taking the highest degree of x term for the polynomial, the limit is simplified to pi. As sin pi equal to 0, the final answer is 0. In order to check your understanding on today's lesson, please do exercise 1.3. Following is the summary of today's lesson. In the next lesson, you are going to learn about continuity of functions.